So what I've done, just before we go into that, I don't know the audience in terms of whether people have experience of Terraform or whether they have no experience of Terraform. So the way I've just put this pack together is really to sort of just to tease out what the basics are with Terraform. We'll get through that quite quickly and then go into some of the more interesting things that you can do with Terraform and why sort of quite a lot of the DevOps engineering world sort of take to it and use it. So hopefully that'll come out in the presentation. So if I can share this screen, we'll go with, I think we'll go with that. And then you can tell me if this is actually presenting or not. Do you get a screen there?
Yeah.
Excellent. Okay, so let's just start with the basics and then what is Terraform? Why is it around? It's a code tool for infrastructure as code and to help you provision infrastructure in any cloud. It can also provision services. It operates at different levels. The idea behind it is that it's a bit more human readable than some of the APIs that you get from the native cloud providers. So it's like AWS or Azure or Google Cloud Compute and other things. It allows resource graphs to be built up and you can see them and then you can evaluate how things are mapped. We'll look at that in a minute. And it basically provides a management workflow, and that's really key to this. So it provides a mechanism to allow you to plan what you're going to do, to see what you're going to do, and then finally, if you want to, just to remove everything that you have done. Basically, Terraform comes in two flavors, really. You've got the core Terraform code, which is basically the main language. And when you hear about versions, that's what people are talking about. So they talk about Terraform 11, Terraform 12. And then you've got the various providers. And as I said before, these could be infrastructure as a service providers, such as AWS, Azure, Google Cloud Compute. They could be platform as a service, so you could manage a Kubernetes cluster. Or they could be software as a service, such as DNS or HTTPS or something like that. And the resource graph that basically is a sort of a little image picture at the top there is basically just to say how things are related to each other. So from this example up there, you've got a subnet which is dependent upon a VNet. Subnet could have a network security group association, which is made up of many or one NSGs, network security groups, and that network security group could have many or one NSG rules. And it basically allows you to build up those resource graphs using Terraform, but Terraform actually will work all of that out for you. So you don't find that you need to set up many dependencies. In some declarative state languages, you often find you need to set up all the dependencies and tell the language what the dependencies are. Terraform will actually work those out for you. The Azure resource provider, the URL links there. I think the URL, the resource provider for Azure has developed terrifically over the last couple of years. I started using it in anger on Azure about 2 years ago. At that time, Terraform 11 was around. Azure was migrating from Classic to Resource Manager. And the Azure provider was really only coping with about 50 or 6 high-level resources, so things like virtual machines, networks, that type of thing. If you actually go to the provider and look at the Azure provider, it's actually very, very detailed. And in some respects, myself and many of my colleagues actually, we find that using the Terraform provider information, not just for Azure, but also for AWS and for Google and the other cloud providers, it's actually more detailed. You actually get more information. And I've got an example there where the API for managed disks that you get from Azure, it's telling you need a location, and then you need to fill out a properties.creation data field, and it says you need to put type creation data. And you think, what the hell's that? And you actually go to the corresponding Terraform page, and it says, well, actually, what that is create option, and here's the values that you can supply. So it's telling you what you can actually use, and those options, the create options there, are what you'd actually need to fill in the properties.creation data for the API. So it's actually very, very useful, very detailed, and very helpful. To get started with Terraform, you can authenticate to use Terraform in a number of ways. The easiest and simplest way is obviously authenticating through the Azure CLI. So as soon as you do something like AZ login to log into Azure, you've effectively authenticated your session. You could then run Terraform code against Azure. You just need to have a copy of the Terraform executable and the Azure provider, and away you go. What you tend to find more in production environments is either authentication using a managed service identity. So you set up a virtual machine and you'll authenticate that through managed service identity. And then obviously when you're logged into that machine, you can then run your Terraform code, or you'll do something through a service principal using a client certificate, or you can use service principal with a client secret. And the way we do it within HMRC for the project I'm working on is the last one, which is service principal with a client secret. We find that's most useful for the team that I work within. It's quite a small team. We're not passing the credentials around many people. So we know who's got that credential, we know where that is, but we also know that we've all got the same service principal, we've all got the same level of access. We all know that if one person hits a problem, then we're all going to hit the problem. And in terms of RBAC privileges for service principal to do what we need to do, which is primarily building virtual machines and building NetApp appliances, virtual NetApp file appliances, looking at subnet rules, etc. We find that all we need is reader and virtual machine contributor. In actual fact, the privileges we've actually got slightly less than that, but if you had those two RBAC privileges, you'd probably find that you could do most of the things that you need to do within Azure. In terms of setting up, it's actually very straightforward. You've actually got those workflow commands I talked at the beginning about, things like Terraform init, Terraform plan, Terraform apply. Those are the actual commands that you need. And actually, to get you started, you actually need a very small amount of code. At the top of the block, top of the page there, I've got a block of code that says Terraform, and it tells me that I need a reversion. And in this case, I'm going to say I want a version that's equal to or greater than 12.6. And you need a provider. And this is where you declare the fact that you're using the AzureRM provider. You're then also, I'm also telling it that I've got a subscription ID that I want it to run against. I then got a nice little line saying skip provider registration. Now, the reason I've got that in my code is because I want to run Terraform behind a firewall. And I don't want Terraform to try and reach out to the internet to try and bring the provider down. I'm going to set up my environment so that I've already got the provider loaded in on my machine, and I can run it without having to need internet access to go out to Terraform to bring down the provider. Now, in other cases, you could have that set to true, and then as soon as you've got your Terraform executable on your machine with that block of code provider equals, it will then just basically go off to the internet to download the AzureRM provider, and you're good to go. And you'll notice there that I've got a subscription, which is var subscription ID, which is a variable, and I obviously need to declare that variable. So I've got a variable section saying, I'm going to declare that variable. And that basically, that bit of code is all you need to basically do a Terraform init, and it will then run and basically initialize. That's all you need. The basics for Terraform. what you've got in Terraform is two type of resources, really. You've got resources, and then you've got data sources. Resources are really the thing that corresponds to the Azure APIs for Azure, or for AWS to be the AWS APIs. So in this case, I'm using the AzureRM storage account. I'm telling it things like the name of the storage account, what I want to call it. I'm telling it what resource group I want it to be in. I'm telling it the location, and then there's some other information like the tier, the replication type, etc. So the information that you typically need to supply to the CLI, or you'd need to supply to the API, you're basically providing it in JSON format with your resource declared, and then all your fields that you need to supply below that. Obviously, a storage account obviously needs a container. So underneath that, I've then got another resource which is going to create the container. And as you can see, I'm actually saying that the storage account name is based upon the item that was created in the storage account above. So the key thing here is that the resource Azure storage account is called demo. And then in my code, I need to refer to AzureRM storage account demo. And in this case, I'm interested in the name. So the name field is the one that I want to put in there. And finally, looking at the resource groups at the bottom, the data sources, I've got a pre-existing resource group. In this case, it's called MB NetApp Files POC. And I need to basically get Terraform to go away and query that to find out what that resource group is, to basically bring back the ID of that resource group, so that then when I reference it in the storage account, it knows where the resource group is. And that's basically the construct of Terraform. You've got data sources which go away and read things that are in Azure in the real world, and then you've got resources which are being used to create or modify existing objects that exist in the real world. Once you get past the basics of what are the main structures of your code, where you've got your resources and your data sources, you then need to think about how you're going to structure that code. And typically what you want to do is basically think about the blast radius. And what this basically means is you don't really want to write something that's massive and monolithic and it's got all your resources declared and basically is one great big piece of code, because the problem with that is it will take a while to run, because Terraform will obviously going to have to validate it all. But also, if you do accidentally do something silly like do a Terraform destroy, it will actually destroy the whole lot for you. It will ask you if you're sure, and if you say yes, it'll go away and then just go away and delete it all. So what you're going to want to do is you're going to want to, first of all, think about how you can structure your code in modules, and we'll have a quick look at that in a minute. But you also want to think about how you can structure your code so that you're grouping things together, like-minded things together. Now, for us on the HMRC project I'm working on, that's fairly straightforward. We've got a very large service that we're migrating to Azure. We've got many servers that we would call application servers. We've got many servers that would be database servers, and many servers we'd have in the web tier. And so grouping it by those constructs is fairly obvious, and you think, oh, that's how we're going to group it together. If you're doing ones and twos of servers, or small servers, then obviously you might group them by those ones and twos. But you certainly wouldn't want to say, oh, I'll have all my infrastructure servers all in one bit, and that you have 100 servers in there. Then I think you'll start to find that you do get issues and problems, particularly when you're coming around to do things like migrating your Terraform code from one version to another. The other thing that we'll talk about in a minute is how to use workspaces to try and help you manage and reduce the amount of code that you need to write, and also how we can use something called Terraform State data source to help you build pipelines and help you actually enable teams to work together collectively. So I talked about modules, and modules are really straightforward. What we've got on the left-hand side of the screen is basically two resources, which are basically to build an Azure backup vault. So at the top resource, we've got the Recovery Services Vault, which I'm going to call in Azure, in the real world, I'm going to call it Demo Recovery Vault. In my code, I'm going to just use Demo Vault. And then below that, I've got a policy. So I've got AzureRM backup policy. So I've just got the two resources there. Now, if I want to make that a module, what I can do is, first of all, I might variabilize some of this. So, for example, things like the name, the location, the resource group, I think I might want to pass them into the module. And then what I want to do is then in the module refer to the variables rather than to the data AzureRM resource group .demorg.location, for example. So the top bit of code that you see there, module recovery vault, first of all, it's got a line saying source. Now, in this case, my source is coming off my computer because I'm using that reference. Typically, what you would do is obviously have a source that's referencing a GitLab or GitHub. You can version it within here. I can show you that in a minute. And then I'm actually declaring what variables I'm going to pass through to that module. So I'm going to pass in the name. I'm then going to pass in a location, which I've got from my data source, which I talked about earlier, and then I've also got my resource group that I've got from another data source, and I'm then going to pass that into the module below. And that module, all it is the same, is effectively exactly the same code. It's just with variables now defining what those values are. In terms of how the code actually looks in the on the screen, what the code actually looks like, can I break out of here? Yeah, break out of here. If we actually go and actually look at what that code looks like, for example, if I can remember which one it was in. And I think it was in 3, I think. Yeah, there's the vault and all the rest of it. So if we look, so we got the vault there. Can you still see my screen, by the way?
I think we're still seeing your PowerPoint.
Ah, right. Yeah. Okay, so the PowerPoint there. Let me just change that. As I told you, I'd struggle with this. Let's do that then. Right, where's Teams gone? There we go. If I end that, let's share the desktop because it'll be easier. Have you got the desktop now? Is that coming through?
Yeah, it is, yeah.
Brilliant, excellent. So if we have a look at the vault, what I've got here is just a directory structure. I've basically got some files in there. So I've got my data.tf, which is defining what data sources that I want to get. So in this case, I want to get the resource group, and I actually want to get a VNet as well. So I'm probably in the wrong one, actually, but there we go. And then if I cat vault, oh no. So there's the actual there's the code to create calling the module. So that's actually called to passing it through, and then as well as the data. Finally, the only thing I've got as well is the variables. So So there's the variable described for the subscription ID in this case, and that's it really. So that's all I need to put that together. Let's just go back to this. Let's put that back on. So that's basically how you take take the resources and then just build up a basic module. One of the other things you can do with Terraform is use something called Workspaces. Now, what Workspaces by default, interesting, the default workspace that you get when you're running Terraform is default. But what you can do is you can to try and dry out your code, to try and reduce the amount of code you're having to write. Because typically what you're doing, specifically, especially with virtual machines, you'll have a virtual machine in dev test, you'll have a virtual machine in maybe your pre-production environment, you may have a virtual machine in your production environment. And the things that change between that virtual machine won't necessarily be the content. It might be the size of the virtual machine. You may get a slightly bigger one, but typically what's going to change is where it's located in terms of the resource groups, or it might be, as I say, the size of the virtual machine might change. But other things associated with that virtual machine, such as how it's provisioned, what script it might run to once it's provisioned, etc., that's all going to be the same. And rather than having multiple blocks of code, so this is how we do dev test, this is how we do pre-prod, this is how we do prod. A way of actually reducing that is actually to introduce something called introduce something called Workspaces. And the way you actually migrate around Workspaces is using the Terraform Workspace command. You can list the current workspaces, you can create a new workspace, Terraform Workspace new, and you can use Terraform Workspace select. And then within your code, what you've got is this thing called Terraform.workspace, and that then allows you to define what those are. So typically for this, I've got two workspaces there. I've got the default workspace, and then I've got the DR workspace. And then I'm setting up some variables, in this case, an image resource group, a network resource group, and a default resource group. And then what I'm going to do is run some code that's going to do a lookup, basically, and then based upon what my workspace value is, it's going to return those values, and it's going to return them as a map. And then I can actually interrogate that map and then use that accordingly in the rest in my code. So you can see that you can have one piece of code, you can refer to the Terraform workspace in that code, and that will allow you to run that code across multiple workspaces, and then you don't need to basically create the code multiple times. And it's one of the things within the Terraform community is that's quite what people try to do. They're trying to minimize the amount of what they call boilerplate code that they're having to write, because it's basically the same code over and over again, and they're trying to reduce it. And one way to do that is by using workspaces, and they work very efficiently. You're recording this, so I can't actually give you a demonstration of that. I'd love to give you a demonstration of that, but because it's being recorded, I probably ought not to, because I was going to do that on a machine where we could see that. The other thing that we use a lot, and I don't see this very often, it's something that a colleague of mine did when he was working on another account, and we've started to use it quite extensively on the account that we're working on now, or that I'm working on now, and it does make a big difference. And basically, it's using Terraform's remote state feature. So unlike, I know you probably correct me on this, Nick, but I'm not sure. Does ARM allow you to actually copy data away and then use that data in another ARM template? I don't know if you can do that or not. But in Terraform, what you can do is you can basically take the outputs from one Terraform run and then use those outputs in another Terraform run. And that's really powerful. Because what that means you can do, you can start to build up some really nice complex pipelines. And what it also means you can do is you can actually look at how teams are going to work, and you can start to make teams work really effectively. So one of the problems we have, or one of the problems we had with the account that I'm working on now, is that we've got a dedicated team that looks after the networking. So they will define the virtual network, they will define the subnets, they will define the network security group rules that are applied to those subnets. And then the engineering team that I'm within then comes along and then, first of all, doesn't quite understand what the networking team have done, that needs to have a conversation with the network team to try and understand what the different subnets are going to be used for. So you end up with a bit of communication and hold up basically at the start, trying to work out what everything is used for. And then if you don't use Terraform State, what ends up happening is each of the developers then goes off and then creates loads and loads of data sources, all trying to do the same thing to try and understand what this other team has created. So what we do is we use Terraform State. We basically write a module that interrogates the network and the subnets, and then writes output defining what those subnets and networks are used for. And then the rest of the team, rather than having to worry about all the different bits within the virtual network and the subnet, can then use the outputs from that first module to help them, or rather to use that to write their modules. And I'm going to go on to a bit of a demo with that in a minute, and how we use that and how that can be used. The other things that you can use Terraform State for are things like where you've got lots and lots of constants. So in a big development such as ourselves, you're going to find you actually get quite a lot of constants that come out. Lots of things are going to be the same. Rather than actually creating them and recreating them and lots of different code, what you can do is obviously create them in this one module that's basically going to be your constants module, create all the constants, it writes it out to a Terraform state, and then all you need to do is then read that state and you've got access to all those constants. The other thing it can be really useful for, is Terraform and resource locking. So one of the things that is quite difficult to do is if you're trying to implement resource locks within your Terraform code that you're actually now currently running. The reason it's difficult is because you're basically going to get Terraform trying to do something and then the resource locks trying to do something, and basically the two shall never meet and you'll end up with a bit of a car crash. But what you can do with Terraform State in this respect is you can basically create your resources, you can write the IDs away to the Terraform state files, and then you can have a module which is called locks, which then reads all those state files and then locks all those resources. And that gives you a nice simple pipeline. You know where you are, and then if you want to actually unlock the resources, you just go onto the locks module and say destroy the locks, and it just destroys all the locks, and then you're off onto your other module which you do to do your Terraform apply, and that does all your changes, etc. And then you go back to the locks module and then reapply the locks. So that can really be a real benefit. That can help enable you to make sure that not only have you created your resources, but you've also locked them away. Okay. So looking at that subnet problem that I was talking about. So where this becomes an issue is one of the things about Azure, it doesn't allow you to do, you can't tag a subnet. So if your network team, typically like our network team, the way they create the subnets, they've got some lovely names, and the names will be useful for them in terms of telling them what the subnet is. So in this case, they've called it NC 122.10.1.1.0-24. And I'm guessing that's going to be a 10.1.1.0/24. And then they've created another one, which is 10.1.2.0/24, etc. Now, that's all very well, but it means that I've got to constantly remember which one is the app tier or the DB tier in this case, and which one is the web tier. And there's no way I can find that out. I can't actually, from Terraform, I can't say, can you query this VNet and tell me which one is the web tier and which one is the DB tier, because it doesn't know. All it knows is I've got a subnet called N122.10.1.1.0/-24. But what you can do with a state file is, as part of the creating the resources, you can create some outputs where you tell it what that actually is. So on the output side there, I'm saying, let's output the web tier name as the value of the name of that subnet. Let's output the web tier ID as the ID of that subnet. And then for the DB tier, do exactly the same thing, output the DB tier name and output the DB tier ID. So I've now got information that's being written to the state file, which is actually useful to me, because rather than saying it's 10.1.1.0/24, I've actually got something that says it's web tier ID or DB tier ID. And that means that as me as a developer, I don't have to then go and look at another spreadsheet to say, which subnet did we put the databases in and which subnet did we put the web tier in. So in the code, all that I need to do in my code is I build up a Terraform remote state based upon network. So basically, I've got a storage account which is basically got the key of network.terraform.tf state. And I know it's an Azure backend, and I know I'm also using the workspace in here as well. So we have different ones for DR as we would do for production, for example. And then in my interface definition below at the bottom, you can see that I'm actually then starting to refer to the subnet ID as data.terraform remote state network out.id, or works in this case, just move that out of the way, web tier ID. So I'm using Terraform State basically to help clarify our code. And the other thing that's useful about this is if you make changes to your virtual network and you add in some additional subnets for whatever reasons, then basically in my code I can then just refer to the new names whichever the person decides to allocate to those. And you see this not just places where you can't use tags, because if you've got tags, then obviously you can query the tags. So you could say if you were able to put a tag on a subnet, you could obviously query the resource where the tag equals so and so. But anywhere you don't have any tags, and there are quite a few examples within Azure where tags don't get created or aren't created, this is another way of enabling you to find the code and resolve that problem. Right. So looking back at history, some of the things that happened prior to Terraform 12. In Terraform 11, the logic within Terraform 11 was pretty limited. Code, as I said there, is complex, verbose, difficult to achieve simple outcomes. And as I say, there was confusion sometimes between migrating from classic resources to the Azure Resource Manager. And the community was harping on to basically the Terraform engineers, the creators of the code, to try and make the code simpler. And one of the things that they desperately crying out for was logic to process loops or maps or arrays in a sensible manner. Now, the first block of code that you see there is something I had to write to enable a virtual machine have multiple disks. So in our environment, typically on our large servers, we've got something like 26, 27 disks. Even on the small, medium-sized ones, we've got 2 or 3 managed disks. And we also needed a way of enabling people to add more disks as the extra storage is required. And we wanted a way that Terraform could manage all that, and had to come up with this horrible piece of code which has got elements and splitting, and it's got counting the index and all sorts of things going on in there. And you're not really sure what index 2 is or index 3 or index 4 is. And you just have to rely on the fact that that code works, and it's all very nice and, well, it's not particularly neat. That can be replaced quite simply by the code that's below. So all we've got down below is we've got this lovely for each statement, and then we've got a variable which is local attached disks, which is actually a map, and that map has got in there basically information such as the LUN, the caching value, and the write accelerated write accelerator enabled value. And it's much easier to read. It's more obvious to read what's going on there. Anybody coming along, picking up this code, trying to understand it later on, trying to debug it, will have a much better chance of being able to debug what's actually going on should there be a problem with this code. Whereas the top piece of code, which is what we had with the Terraform 11, it's very obtuse. Unless you had probably written it, you probably wouldn't really understand what it's trying to do or why it works. Some other nice features of Terraform. I think ARM templates have got the same thing. You can use the count feature is pretty much available in all resources, and typically what we use it for in Azure, in Terraform Azure, we use it quite a lot to say whether we want to do something or not. So, for example, you may have, in order to dry your code out, you may have found that you've got some exceptions. So a good exception might be, for example, when we started writing the module for the Linux VMs, where there was a restriction on the number of disks that Azure Backup would manage. So whilst the majority of our servers we could actually use Azure Backup to back them up, we found that we had a handful of servers that we couldn't enable Azure Backup on because they had too many disks, and or we just get Terraform errors and etc. and all the rest of it. The way you can get around that is one of the first things you can do that is you can introduce a count function, and here we've got a count function saying local deploy $1:0, and basically what that means is if local deploy is set, then I want the count equal to 1, and if it's not set, then I want it equal to 0, and if it's equal to 0, then Terraform won't do anything with it. So then I can have in my code, I could have a variable called local deploy to say either set it to 1 or set it to 0, and then typically what we'd had in our backup structure, we might have something like perform backup or backup this resource, yes or no, and then we'd actually interrogate that value, and then that would either run the Terraform code that would do the backup or not. The other thing that we talked about there was maps and how you can use them. And oops, sorry about that. Go back to. Let's just move that out of the way. The other thing you can do there is we've got a map called allowed clients. It's got an index and it's got an allowed values. And then we got this dynamic for each again. And you've seen that before, actually processing that, just basically how you can process that map. And again, it's quite straightforward. It's fairly obvious. The other thing that's quite nice about these for eaches is that actually they can be nested as well. So within the Terraform code I've got for managing as my Azure NetApp files resource, I've actually got the dynamic block, which is for the policy rule, and then outside of that I've got another each statement that is actually managing other parts of the code. So you can actually nest them as well. So that's quite powerful. One of the things that Terraform does have as well that you don't see very much, but it's really useful, is templates. So one of the things we do with our VMs is not just do we create them, but we also set up all the metrics for them. So rather than having to go into the portal after VM's created and then click on the metrics to say, yes, we want metrics collected, thank you, we'll do that all within the Terraform module. And the way we do that is using templates. So you can create a JSON template file. On the left-hand side of the screen, you've got a typical template file that's for metrics. That's basically telling you some of the information that needs to go into that template file. You can also pass variables in. So in that example there on the left, we're passing in the VM ID and we're also passing in the storage account name. And then on the right-hand side of the screen, we've basically got some code which is basically saying we're going to use a template file and we're going to pass in the variables of VM ID and storage account name. And that's a really powerful thing that you have within your modules. You can have templates obviously within the modules itself, and that enables you to A, cut down on your code, and B also do things that would that such as wherever you can think where templates would be useful is how you can actually use them. And in our particular example, we're using them to actually set up all the metrics that we want to collect on the virtual machine. So as we build the virtual machine, we also set up all the metrics that we're going to then collect. Another really useful thing about Terraform is you can override its normal behavior. Now, this is really powerful and really useful as well. And it's been a lifesaver for us because I'll come on to why it's been a lifesaver. But you can create something called a lifecycle policy. You can have lots of different options within lifecycle policy. Two of the ones that are really interesting: prevent, destroy. That's quite handy. So I use Terraform to, as I say, to provision Azure NetApp volumes. Now, one of the things I don't want anybody to do is accidentally delete my Azure NetApp volume, because my Azure NetApp volume is 2 or 3 terabytes in size. It's got all sorts of data on it. And whilst it might be backed up, the last thing I want someone to do is run a Terraform apply. For whatever reason, Terraform says, oh, I'm going to go and destroy that NetApp volume, and then I lose all that data. What I can do within at the top of the resource is introduce a lifecycle event, which says, in this case, prevent, destroy. And that basically will prevent Terraform from accidentally running the destroy part or on that Azure NetApp volume. And there are ways that could happen accidentally. So, for example, if somebody copied the code and decided to do some changes but forgot to amend the state file that they were looking at, they could then run their code and then they were actually using my state file that I want, which has got the Terraform, the NetApp device defined in it, and they could accidentally blow it away. Other things that are really, really useful are ignore changes. So this is really powerful when you're using things like Azure Backup. So if anyone's actually used Azure Backup or Azure Restore, one of the things that you find when you run Azure Restore is all of the objects that get restored, the virtual machine, the disks, they all come back with different names. So you understand what the names were, but when you look in Azure, they've all got lovely extensions on, like the timestamp when the restore was run. So that's a problem for you, because you've lost your VM, you've restored it, and now it's all got different names. So you think, okay, I'll go into Terraform and I'll rename everything so it's got the same names as the real world objects that have just been restored. You've then imported everything, so you've imported it all back into Azure, and you think, right, I've got it all now. You run your Terraform plan and it says, oh, I'm going to destroy everything and rebuild it all again. And so to overcome that, you can use lifecycle changes within the resource to say, ignore these specific changes. So the ones that we're ignoring there are things like OS profile. Now, why do we do that? Well, we might, for example, have built the virtual machine using an image that was, say, Red Hat version 7.5. We've now upgraded it to Red Hat 7.8 or Red Hat 7.7. And we've then restored the code. and for some reason it still thinks it's Red Hat 7.5 within the image, even though it's actually Red Hat 7.8. You run your Terraform apply and it blows it away because it thinks it's 7.5 and actually it's not, it's 7.8. So you can actually do some really useful things in here to stop Terraform doing things because it thinks it's doing the right thing when actually, because of something, other events that have happened, it's not the right thing. Another one where you get problems is when you create images, often, or when you create VMs, you'll often create a virtual machine from an image. So you might have you've got your Red Hat image, or your Oracle Enterprise Linux image, or your Windows image, and you've got your code to actually say that's what I want to use. When you restore a virtual machine, the way it references that is different. So although it's from image when you created it, when you restore it, it's from disk. So it's different. And the Terraform thinks, oh, there's a difference. I'm going to destroy that machine and rebuild it. And you don't want it to do that. So you can use lifecycle changes to ignore those ignore those things that are changing. And Terraform will then say, oh, okay, I can see that's changed, but I'll ignore it. Now, it won't ignore the whole section. It won't ignore the whole of AzureRM virtual machine. It'll do the other things that it needs to do. It'll just ignore those bits that are have changed, if you like. Okay. Things can go wrong. They often do. Here's an example where we're using soft delete on the recovery services vault. So what's happening here is you've got the situation where you've effectively got two things trying to manage the same thing. You've got Terraform trying to manage something, and then you've got recovery services vault trying to manage something. Now, soft delete is a nice feature because basically it means that if you accidentally go and delete your backup data, what Azure does is say, oh, I'm going to keep that for however many days. And you set up your policy on soft delete and you say, I want to keep the data for another 7 or 8 days, even though I've just deleted it. The problem that Terraform has got is it deletes that backup data, and then it doesn't understand why it hasn't gone. It's complaining. It's thinking, I've deleted that. Why aren't I deleting it? So here we have an event where soft delete's been enabled on Recovery Services Vault. I've created a virtual machine. I've instructed the machine to use Recovery Services Vault. In this particular instance, I hadn't even done a backup on the virtual machine. I just said, use that Recovery Services Vault. Terraform then tries to destroy that VM, and after 1 hour or 20 minutes, it gave up. So it just continued running until it just timed out, basically, and that was it. And you can get in that situation very easily with Recovery Services Vault and virtual machines. In fact, if you're using Azure and you're using Azure Backup, I probably would recommend turning soft delete off because it could give you some nasty headaches. Some other things that can go wrong. Naming policy. Naming policy can be a problem if you have a awkward or a bad naming policy that doesn't really allow you to write automation very easily. And what I mean by that is typically when you're creating your code, you might want to do things like, say, I've got a virtual machine, and that's the name of that virtual machine. If I add a disk to it, I want to call it virtual machine name -disk 1, virtual machine name -disk 2, virtual machine name -disk 3, etc., etc. Or I might have NICs. I might have virtual machine -NIC 1, virtual machine -NIC 2, virtual machine -NIC 3. If you've got a policy where the objects for NICs and the object for disks have different naming structure to the virtual machine, then your code gets really messy very quickly, and it's quite difficult to then pull that all together. And a bad naming structure could increase your workload quite significantly when relatively speaking, writing the code to actually create a unique name for a disk or a unique name for a NIC, if you've got multiple ones of them, should really be very straightforward, and it falls nicely into the looping constructs that you've got. Whereas if you've got a naming structure that's got bits of this and bits of that and it's all tagged together, it can make it quite difficult. The other thing to watch out with Terraform is maps. When they're combined, they get sorted. Now, we do that quite a lot. We combine our maps in our code. And what I mean by that is we might have a map which has got some default values. And then we might have another map which is consisting of all the actual detailed values. And what we might then do is merge the two together. And that one means that our code's nice and dry because I haven't had to put all the default values in amongst all the other values for the other bit. But what will happen is it will get sorted. And the problem with that is that if you don't think about it, you might find that your creates work fine, but when you come to do amendments, you might find you've got issues. So, for example, if you've got, say, something like network interfaces on a virtual machine, and you've got a lot of them, or more than one even, and let's say you start with 2, and you create the first one as AAA and the second one as CCC, and then you put a third one in called BBB. Terraform will sort them. Now, it won't add the BBB onto the end. It'll actually delete C, add B, and then add C in. So you need to be careful if you've got how you set up your maps, and make sure that you can handle the fact that if somebody comes along and adds or deletes something, it doesn't then force Terraform to then go and actually start rejigging what's happening in the real world and start deleting or adding your resources. I mentioned blast radius. Blast radius is interesting. I mean, I had followed all these good practices, and I had set up our structure so it's hierarchical, so that we had different parts of the code were for doing this, and different parts of the code for doing that. But of course, what you can't override is someone who comes along and then says, "Oh, I'll parallelize my Terraform apply commands," and of course, that then means that something that relatively should have had a relatively small blast radius, if somebody comes along and then says, "I'm going to run everything in parallel," obviously undermines all of your good hard work to try and reduce the blast radius, and then you've got something that is a much bigger blast radius. And in this particular case, unfortunately, they were parallelizing a destroy, which wasn't what we wanted at all, and so we lost one of the environments for a few days while we tried to get it back. Azure Site Recovery is interesting. So Azure Site Recovery, what Azure Site Recovery does is, as anyone knows who's used it in anger, when it's creating the resources in the disaster recovery site, it's basically setting up a copy of those objects. Now, if you invoked DR, you then think to yourself, actually, how am I then going to manage them? How am I then going to manage those resources that are now in my DR site, because I haven't got any Terraform code associated with them, because they've all been created by Azure? Now, that's relatively straightforward. You can, I mentioned it very briefly, you can use something called Terraform Import, where you can actually import the resources into the state file. So you've got your code that says, this is what my disaster recovery area looks like. So I might have a number of virtual machines in there, I might have some storage accounts, etc. You can obviously create that code that will mimic that, and then you can import those resources into Terraform State. And you think, great, that's good. That's all going to work well. The problem you find with Azure Site Recovery is when you run a test, the names of the resources are different to the names of the resources when you actually invoke DR. So you've then got, well, what do I do then? Do I have two different bits of code? And that's where you then come back to things like Workspaces, where you can actually then write your code to say, if I'm running a test, I want the objects called this, and if I'm running DR, I want the objects called that. And then when you do your imports, the objects will get imported in. And when you do your Terraform applies, etc., they'll all work them out, and it'll all sort itself out. But just be aware of Azure Site Recovery, just to be aware that objects are created with different names when you're running a test to when you're running it for real. And that's quite valid as well, because you don't want the objects to be the same name, obviously, if you were only running a test. We mentioned recovered VMs and disks from backup because of some of the attributes associated with that change. And you need to be a little bit careful about that, because when you run the restore, some of the objects, when they get restored, obviously they come back with different names, but also some of the attributes of those objects get changed, and then Terraform thinks it's a change and then tries to modify it, and that's not what you want. One of the biggest things that can cause problems is people copying code and then forgetting to change the state file. I've seen this a number of times. One of my colleagues, when he was quite new, it was a few years ago actually now, or a few months ago actually, I'd written some lovely code and he copied it all and said, "This is great, Chris." I forgot to change the state file because he was doing something different. And he said, "Chris, why am I destroying all your objects?" And it's because he didn't change the state file. So basically what he's done, he's copied my code, he's copied my state file, which is held within Azure. But as he's copied it, he's pulled it out of Azure, pulled it down to his machine. He's then done his changes, hasn't realized he hasn't changed the state file. And of course, as far as Terraform's concerned, it doesn't know anything about all of those things I created. It only knows the things about my colleagues has created, and then it goes and tries to destroy all my stuff. The other thing that you've got to be careful of, excuse me, I get a drink of water. The other thing you've got to be careful of, external resources. You want to make sure they are idempotent as a minimum, i.e. they can be rerun. So if you've got any scripts, so if you're using, if you've got in your virtual machine, you call out to an external resource to run a script, and that might be a script to say run an Ansible script or run a Puppet script, or it might just be to do a yum update. As long as the script's rerunnable, then that's fine. But if it isn't, then that's going to could cause problems. Because if the script comes back with an error, Terraform thinks, "Oh, it's failed," and it will start to try to recover from that, and the recovery action could be not what you expect it to be. So, a couple of things that are worth noting. If you are interested in what's currently going on within Terraform, always look at the change log. The GitHub community maintain a change log of what's happening within the and what bugs they're currently working on. So you often find that as new features are introduced in Azure, the Terraform community is a bit behind them. This happened to us with proximity placement groups. We didn't actually have any code to enable us to create proximity placement groups. So a colleague of mine got the Go code that's used for Terraform, did a pull request and wrote the proximity placement group resource that's now being used by a number of people, I imagine. So you can watch the change log, and you'll often find in there people will raise requests for new features. There's another thing that happened with Azure NetApp files. NFS version 4 support wasn't in the initial release. A lot of people obviously said, "Well, why isn't it there?" There was also no ability to tag anything. And you'll find in the change log, it will actually detail when they're actually releasing those fixes. The other thing you can actually see as well is what's coming up with Terraform 13. Terraform 13 is basically being created now, and there will be a migration for people to Terraform 13. The big one for everybody in the community is the ability to have count on modules. that is going to make amazing differences to people's code. It's going to reduce people's code quite dramatically. We've already looked at some of our code and thought, well, we could make massive reductions in the amount of code that we need to write once they introduce count on modules. So rather than having a section where you have module, create a VM, and then that module again, create another VM, module, create another VM, module, create another VM. You just basically have something like, say, module app tier, count 5, and off it'll go and create 5 app tiers. So that's going to be a big change, and that's going to come with Terraform 13. The other thing that's coming in Terraform 13 is the automation of third-party providers. So at the moment, Terraform's pretty good in terms of the number of providers it's got. It's well over 100. I talked about some of them, AWS, obviously Google Compute, Azure are the big ones. There's others out there such as Power DNS, HTTP management for Apache. There's things like MySQL creation, InfluxDB creation. There's all sorts of things out there you can go and have a look at and see how they work. But the big thing that's coming with 13 is your ability to create your own, publish them, and then other people actually consume those as well. So that would be interesting. So it's a bit like App Store for Terraform, I imagine. The other thing that's quite important is finally they're going to put some validation on input variables. So at the moment, input variables within Terraform, they're quite straightforward, actually, variables within Terraform. You really only got a few types, really. You've basically got a string, a list, which is basically an array of strings, or a Boolean, and then maps, which is obviously can be anything you like. So maps, obviously, are basically key value pairs, and you can create those key value pairs and then nest into them. You can put other maps, and you can also nest into them arrays and all the rest of it. So actually understanding them can get quite complex. But one of the things that's coming along with Terraform 13 is the ability to validate the input fields, and I think that will actually tidy up a lot of people's code. So I'm coming to the end of the conversation now. I think I'm probably a little bit early, but if we open it up for questions, I'll try and answer those questions. I'm not guaranteeing I'll be able to answer everybody's question, but certainly, hopefully that's given you a bit of an insight into what Terraform is, why the DevOps community particularly like it. It's great for coders, actually. People that are frustrated coders working in the infrastructure space tend to turn to Terraform because it gives them a bit of a buzz. They can actually use their, they can actually develop some quite nice things, and they can obviously get them to do what it wanted to do.
Can I ask you a couple of questions, Chris?
Yes.
So these are genuinely because I don't know and I am interested. So the first one is like the scale of the environments that you're creating. I guess from my knowledge that some of these are pretty big environments that you're managing with Terraform.
Yes. Yeah. So should have told some people at the start basically how big these environments are. So we've provisioned, or we look after, and it's a very small team. So we look after something in the region of 450 virtual machines. And there's a team of, I'd say, 3, because some of them are both part-time. So there's 3 of us that are looking after the 450 machines. We have them across multiple environments. So obviously we've got production, pre-production, dev test. There's lots of different changes going on, particularly in the dev test world. They're often asking for new mini environments to be set up and destroyed. So Terraform is ideal for that. Terraform's ideal as well because to try and do this, to try and do it with ARM, I think would be a little bit complex, specifically around some of the gotchas that we found. And I talked about those things like the lifecycle changes. Some of these virtual machines, like the pre-prod and the production environment, they're not going to disappear. They're going to be there for a long time. So the application that was being run on them is SAP. SAP, for those that know, it's not particularly cloud friendly. And it tends to be in its sort of environment where you provision the virtual machine. We then use something called Puppet as well to perform all the configuration of the virtual machine, and that will look after all sorts of things to do with the accounts, population of the various prerequisites that they need for SAP, etc., etc. And then we hand it over to some engineers that actually go away and do some installations and whatever they need to do with that. But the machines themselves are going to be there in this environment for quite a while. So the things that we found is we've not only used Terraform to provision these virtual machines, but we're using Terraform to basically maintain these virtual machines. And as I mentioned, we're using it to add additional disks or add additional NICs if they want to add extra functionality, or change the size of the machine, or even change the characteristics of the disks, etc. So one of the things we're doing at the moment, we're doing a PVT run, and we found we got some average queue weights seem to be too high, so we're changing some of the dimensions of the disks in terms of attributes such as the caching and the write enable caching, and we're just using Terraform to do all those changes because we've already got the details. And something that would take you a long time in the portal if you're going to do it through the portal, obviously it only takes us a few minutes because we just do the Terraform plan and then Terraform apply. And I say a few minutes, I mean sometimes we have seen, so for example, some of our servers are pretty big. So we've got M-class servers, some of the large 64 CPU boxes with 28 disks on them. You shut one of those babies down, they can take about 20 minutes to shut down, and they can take about 20 minutes to start. So we've got everything really we've got a lot of them, and we've also got very large ones as well as the sort of run-of-the-mill, D2s and that type of thing.
Yeah, my second question was really, what do you use in terms of like development environment or source control and configuration management? How do you do that?
Yeah, so everything we use Visual Studio Code. Now, Visual Studio Code and Terraform pretty much go hand in glove. The extension for Terraform was written by two guys actually were writing the Terraform extension for Visual Studio Code, and it's now been taken on by the Terraform community. So the Terraform community, Visual Studio Code is ideal. So you can, as you're writing your Terraform syntax, it'll check all your syntax for you. You can also use it to run a Terraform run, Terraform plan, and Terraform apply. In terms of where do we store our code, or we store all our code in Git. When I created the module there, I'd actually using it as a local copy, but all of these that we do for production and pre-production and dev test, that's all stored away in Git. So everything's pulled in through from Git. Okay,
and you asked me a question, sort of, which I didn't answer, which was related to, I suppose, outputs from actions and how you would handle those in ARM. I think, I mean, I don't know the specific answer, but what was going through my mind was, if I was doing this, I'd be probably using Azure DevOps as well.
Yep.
So it's almost like some part of the ARM just provides you the resource management capability, but a lot of the sort of logic I would probably implement as part of a DevOps pipeline.
Yeah. And I think that's what I mean, as we've now sort of stabilized our code, and the three of us that have done a lot of the development on this are now handing this over to live services, and they're going to be wanted to do very few and infrequent changes to the environment. Then using something like GitHub Actions to run the Terraform plan, and then put that output into an RFC that they can then get approved by a manager. Then the next action to do the apply is the sort of thing I'm starting to look at now, because that would just go down very well with the live service community. I mean, one of the nice things about Terraform is the output from a plan is what's going to be the output from the apply. You can actually say to Terraform, when you run the plan, save it to this file, and then when you run the apply, use that file. So from a live service perspective, from a what's changed or what will change, it's very nice to be able to go to the change board, and when they say, well, what's going to happen when you run this, you can say, well, this is what's going to happen. Here it is. This is all the things that's going to happen, and then they then feel more confident that you understand the risks of what's going to happen when you run a change.
Mm-hmm. And there's a question from Darren, which relates to: have you seen issues with ASR and disk encryption with the encryption changes?
Yeah, interesting. Disk encryption, yes. So we currently are still using server-side encryption with Azure managed keys. The reason we're doing is because our databases that are sitting on top of it are actually using encryption within the databases, and then we're just going to have encryption on encryption. Yeah, there's an interesting thing. What you've got to do there is you've got to make sure that your keys are obviously replicated into another vault into the DR site. And if those keys go out, then you're going to have some problems there trying to recover those machines. So we haven't experienced it, but I have seen people that have just lost the virtual machine because they've lost the keys to their encrypted disks. Yeah.
Question from Stuart. Do you want to ask it yourself, Stuart?
Hi Nick. Hi Chris.
Hi.
So my question is, what I can glean from what you've just described in terms of Terraform and Puppet is that you've sort of described a desired state configuration sort of environment.
Yeah.
So am I right in assuming that you use that for managing and enforcing desired state configuration?
Yes, we do.
Okay.
Yeah, we do. So so Terraform is pretty much being used for the provision of all the Azure resources, and how we want them to look, and then we're using Puppet inside the virtual machines to enforce all the other things, such as CIS compliance, what packages are on the servers, what installation state the server should be in. So typically for us, if we actually blow away a machine and we want to recover it, we can actually recover the virtual machine. Let's say we recovered it from from using Terraform, so we'd actually just rebuild the machine again, and then we've only got 3 directories that we need to recover from the backup server, and that's basically because that's got state in that isn't being managed by Puppet, and we've done that successfully now on a couple of times. Sometimes by accident, sometimes deliberately. But basically it's written so that if we do blow away things like /etc, then we can recover it just by running a Puppet run, and it builds everything else that we need in etc. And then we can just recover any data files that we need that maybe that we're obviously not managing with something like Puppet.
And does that automatically happen if there's malicious or accidental change to the infrastructure?
Not currently. Well, actually, what it would do actually. So Puppet runs every 30 minutes on our boxes, so it will actually bring them back in line after 30 minutes. Yeah.